Welcome back to another video, and today's topic is mainly about angles. Now, when we hear about angles, right, we're gonna of course have to use a bunch of like rays and segments, right? Because last video we talked about all about points, lines, and planes, and of course with the addition of rays and segments. But what is an angle exactly? So an angle is basically something that has a degree of it. So in geometry, we usually just use degrees, but once you advance into further math like calculus and algebra 2, sometimes you're gonna have to start using radians, right? So if you're using your calculator, make sure that it is set to degree mode, because when we have radians and degrees, they don't match up necessarily. So the sine of 30 degrees could be different from the sine of 30 radians, okay? So now we need to understand there are two different types of angles. Well, there's more than two different types, but as in the numerical value, there's two different types. We have one for 90 degrees and we have one for 180 degrees, right? So our first type is a complementary angle. Now, a complementary angle is just they add up to 90 degrees. They complement each other, right? A simple way of figuring this out is that CO, the beginning terms, right? CO, that looks like a 90 to me, because if you just put a, think about this, if you just put a line with this next to C, you get 90 degrees, right? So we know that this is 90 degrees now. And we're going to write that it's 90 degrees. So now what would it actually look like? It could look like something like this, where you have this, you have that, and you have a 90 degree, right? Let's name this A, and then let's name this B. And then you have something dividing the angle, the 90 degrees. Let's name that point C, right? So now, you see, this whole entire angle AB, right? Well, we should have a vertex as well, so let's name that E. So angle AB is just equal to 90 degrees. Now, just because angle AEB is 90 degrees and AEC is complement to CEB, we can write that angle AEC plus angle CEB is equal to 90 degrees, right? It makes sense that way. So now we have another type, which is called supplementary. Supplementary angle. Now this, in this case, is 180 degrees. So as an example that we have, we can make a straight line, because we all know a straight line is 180 degrees. Pretend that's a straight line, right? And let's say we have this angle here. So we have A, B, and C. And of course E over here. So now angle AEB is equal to 180 degrees, right? So that means that angle AEC, right? AEC is going to be added onto CEB to make it 180. So we can write angles AEC plus BC equals 180 degrees, right? But as you might say, writing the word angle all over so many times is just annoying, right? And it's it's a long process. So now what can we actually write as the notation of it then, right? We know an angle is shaped like this, right? This is the shape of an angle. And this is, let's say, angle theta, right? This is our little angle, right? And if we want to signify it, right? Let's say it has B, C, D, right? Those are endpoints and vertex. Let's say we want to signify this as notation form. We can just write the angle, right, of BCD is equal to theta, right? Theta means the degree of the angle, and then this symbol, right? This symbol necessarily just means the measure of the angle. Some teachers do it differently. I like to write it this way because it's, the proper way of writing it. You could have also some teachers write M angle BCD equals theta, right? It mainly depends on whatever is the main focus of it. So some teachers do it differently. Some teachers just write the angle itself. Some people just write the measure and then angle, right? The M in this case means the measure. So we're gonna write here measure, right? And that's the whole entire point of it, right? So now let's see if we can actually go on further in, right? We have more angles on like a graph, let's say, right? So over here, let's say I have this graph. We're gonna try to draw this graph to the best of our ability here. Hopefully it works. Bada bing, bada boom. And then let's do this. Alright, so we're gonna put some endpoints now. AE and then CD, right? Okay, let's say that AE, well, line AE is parallel to line CD. Now, another way to write parallel to is with two vertical lines, right? So it could be AE is parallel to CD, okay? That's just an easier way of writing it. You don't have to write it this way, you don't have to write it that way, but it's good to know. Because on the test, they mainly use the vertical lines to represent their parallel. And we all know that parallel lines, they never meet. So we can draw that on our graph by using two arrows signifying that they are parallel to each other. Now, we're gonna start having some angles here, and let's say that this is angle 1, and this is angle 2. Say this is angle 3. And then we can have angle 4 right here. Alright, so by the looks of this, right, since we know that AE and CD, well, line AE and line CD are parallel to each other, we can say that line GH is a transversal. So a transversal is when you have a line going across two parallel lines. Okay, so that's what it makes sense. Now, this will only work for this case, right? But whenever we have two parallel lines and a transversal, we can have alternate interior angles and alternate exterior angles, right? So now, let's say that angle 1 is congruent to angle 2, right? The main reason why this is congruent is because they are vertical angles. Now, vertical angles necessarily just mean that they're opposite of each other. So we can't say that angle 1 and angle 3 are vertical angles because they're simply not opposite of each other, right? They're a whole different type. So now we can also say that now we're getting to the alternate stuff. Alternate interior angles is when the angles basically they're inside of the two parallel lines, so more near the middle, the center, and they're opposite sides of each other of the transversal itself. So since the transversal is line GH, right? We can say that angles 1 and angle 3 is alternate interior angles. The main reason why is because angle 1 is over here, and then angle 3 is over here. They're opposite sides of the transversal, right? But at the same time, they're also opposite ends of the parallel lines, and also they're on the inside and not the outside. And of course, they're congruent to each other. So angle 1 is congruent to angle 3. What if we wanted to say that angle 2 is congruent to angle 4? Those is what we call alternate exterior angles. So angle 2 and angle 4 is alternate exterior angles, right? And now in this case, we can also say that they are congruent to each other because of the transversal. So angle 2 is congruent to angle 4, right? That's the whole point of this. And by looking at all of this, right, of course there's more angles that we can talk about, right? There's more things that we can talk about here, right? Like supplement angles, right? Because we can see that there are lines there and AE is 180 degrees. So that means that angle 1 and of course the other angle next to it would just be supplement, right? There would be supplementary angle. And even though all of this is true, right? We also have like adjacent angles. Adjacent just means that they're next to each other. So of course, if they're supplement or they're like complementary, then there would be adjacent angles, right? Because they're next to each other. Now, how can we actually, find for these angles, right? There must be an algebraic way of finding the angles based off like what we're given. So let me draw us an example here, which might clear some things up. All right, so in this case, we have two angles, right? And our first angle is angle 4x plus 10, and then our second angle is 3x plus 10, right? So now we're going to try to find each of the angles here. But we do know that it's on a horizontal line, and that line is 180 degrees. So we must know that these two angles that we're trying to find are supplementary angles, right? So that means that when both of the angles are added up, they must equal to 180. So we set that to 180. 4x plus 10, that's the first angle, right? Plus a 3x plus 10 is equal to 180 degrees, right? Don't forget the degree symbol. Make sure that's there. So now we're gonna try solving for x first, and then we can figure out what angles there are, right? So 4x plus a 3x, that's just 7x, right? 7x plus 10 and 10, which is just 20, equals 180 degrees, right? We minus the 20 on both sides. 7x is equal to 160. Oh, this doesn't come out to a good number. Now, we divide the 7 on both sides. So that means that x is equal to 160 over 7. Well, this doesn't look like a good number, right? Now, since we know that the x value is just 160 over 7, right? Now we can plug it back into the equations that we have. So 4 times 160 over 7 degrees, right? Plus 10 is just equal to 4. That's around like 90 plus 10. That's just around like 101 degrees right there, right? And then we got 3x plus 10. That's around 78 degrees. Well, 79 if you round it. So now, since we figured that out, right? Those are our angles, and if we add them up together, we're gonna get 180 anyways, because these angles are supplementary to each other. Now, it's the same thing if they are complementary angles, right? You will still add them up and set them equal to 90 degrees. Now, let me give you another example that you can try on your own, and let's see if you understand it. There we go. And also FYI, whenever you see a box on an angle, that represents that it is 90 degrees, which is a complementary angle. Right? So 3x plus 7. Alright, so take a look at this example and see if you can solve this by yourself. So you can pause the video here and take a look. Alright, so hopefully you guys just solved it on your own. Pause the video, right? And so now let's start solving it. So we know that this angle, this whole entire angle is complementary, right? So we set them equal to 90 degrees. So plus the 3x plus 7 equals 90 degrees, right? So now we add the like terms together, which makes up 8x plus 10 equals 90 degrees. Subtract the 10 on both sides, 8x equals 80 degrees. So it means that x equals 10 degrees, right? So now let's solve for the individual angles here. 5x plus 3, where x equals 10, would just be 5 times 10 plus 3. And that will lead us to 50 plus 3 equals 53. Now on the other angle, which is 3x plus 7, right? That'll be 3 times 10 plus 7 equals 30 plus 7 equals 37. So we know that this angle here is 37 degrees, and then that this angle here is 53 degrees. Don't forget your degree symbol. You see, it wasn't that hard, right? So now let's give you another example. This example will be a little bit harder from the rest, but you're gonna have to use some of what you learned just now. So let's draw this. There we go. We're gonna name this angle theta. And let's say that this is 150 degrees. We're gonna make this a variable here. So 3x plus 10. And then over here, this angle would be 5x plus 5. Right, so now use this and take a look at how you're going to solve this. Alright, hopefully you just pause the video and try to figure this out. Now, there's one thing that we can tell between these, right? We can tell that angle theta here, right, is just the vertical angle of 5x plus 5, right? Angle theta is congruent to angle 5x plus 5 because 5 because vertical angles, right? So now, since we know that this whole entire line segment here, starting from here to here, that is 180 degrees. So we can find x by just setting 3x plus 10 plus the 5x plus 5 equal to 180 degrees. So now we add the like terms here, ax plus 15 equals 180, right? So ax equals 165, and divide that by 8, which gives us x equals 20.625, right? Now, since we know that 5x plus 5 is congruent to angle theta, just because they are vertical angles, we only need to solve for 5x plus 5, right? So 5x plus 5 equals question mark 5 times 20.625 degrees plus the 5 equals 108.125 degrees. So that means that angle theta is equal to 108.125 degrees. It is that simple, right? So most of the problems here, you have to figure it out by just looking at what you have and what rules that, like definitions or theories that you can put on it, like postulates, right? And with all of that in mind, the more practice that you do on these problems, especially during the regions, will help you understand more of it, because most of this is visual stuff, so you have to really look into it and see, like, take all the secrets out of it. So I hope you guys do more practice on this types of problems. If you need help with them, right, you guys can look at some resources, and most of the time everything's going to be good around here. So I'll see you guys in the next video, and of course keep on practicing.